My dear students and parents, in this video we are going to study how to find the limiting molar conductivity of hydrogen acetate, that is HAC. My educational videos are available in YouTube to 10th CBSE, plus 1 CBSE, plus 2 CBSE, NEET and IIT students in the subjects mathematics, physics, chemistry, zoology and botany in English language. The limiting molar conductivity for sodium chloride, hydrogen chloride and sodium acetate are 126.4, 425.9 and 91.0 Siemens centimeter square per mole respectively. Calculate the limiting molar conductivity, that is lambda m naught for hydrogen acetate. In this sum, the limiting molar conductivity, that is lambda m naught of sodium chloride is given as 126.4 Siemens centimeter square per mole. The limiting molar conductivity, that is lambda m naught of hydrogen chloride is given as 425.9 Siemens centimeter square per mole, and the limiting molar conductivity, that is lambda m naught of sodium acetate is given as 91.0 Siemens centimeter square per mole. They are asking to calculate the limiting molar conductivity of hydrogen acetate. In this case, it is to be noted that the AC does not represent the actinide having the atomic number 89 that we have seen in the F block elements. It represents in this case as acetate. Acetate is the ester. Acetate is the ion obtained due to the loss of H plus from the acetic acid. We know that acetic acid is a weak acid. It is an organic compound. The formula for the acetic acid is CH3COOH. Before going to find the limiting molar conductivity of hydrogen acetate, I want to say some information. What is electrolyte? Electrolyte is a substance. When it is dissolved in water, it breaks into, it is split into its constituent ions, that is cations and the anions. What is strong electrolyte? The strong electrolyte is a solution or solute. It is completely or almost completely ionizes or dissociates into its constituent ions, that is cations and anions. The weak electrolyte does not ionize completely. It does not dissociate completely. It partially ionizes or partially dissociates into its constituent ions, that is cations and the anions. These are the informations about the electrolyte, strong electrolyte and weak electrolyte. In the case of hydrogen acetate, it is the weak electrolyte. The limiting molar conductivity of this weak electrolyte cannot be calculated without applying the Kohl-Rauch law of independent migration of ions, so that we are going to find the limiting molar conductivity, that is lambda m naught of hydrogen acetate, applying the Kohl-Rauch law of independent migration of ions. Hydrogen chloride combines with sodium acetate to form sodium chloride and hydrogen acetate. It is a double composition reaction. If we write interchanging the sides, we will get sodium chloride plus hydrogen acetate equal to hydrogen chloride plus sodium acetate. Then if we find the hydrogen acetate from this equation, we will get hydrogen chloride plus sodium acetate minus sodium chloride. If we bring this sodium chloride from the left side to right side, it will become as minus sodium chloride. So if we want to find the limiting molar conductivity of hydrogen acetate, we can write it as limiting molar conductivity of hydrogen acetate equal to limiting molar conductivity of HCl plus limiting molar conductivity of sodium acetate minus limiting molar conductivity of sodium chloride. We can also write this applying the Kohl-Rauch law of independent migration of ions. What is the Kohl-Rauch law of independent migration of ions? The Kohl-Rauch law of independent migration of ions states that the limiting molar conductivity, that is lambda m naught of an electrolyte, can be represented as the sum of the limiting molar conductivity of the cations and the anions of that electrolyte. That is, limiting molar conductivity lambda m naught of an electrolyte can be represented as the sum of the individual contributions of the cation lambda plus naught and anion lambda minus naught of the electrolyte. So from this law we can understand that if we add the limiting molar conductivity of the cation and the anion of an electrolyte, we can get the limiting molar conductivity, that is lambda m naught of that electrolyte. Here there are 4 compounds, that is there are 4 electrolytes. As per the Kohl-Rauch law of independent migration of ions, this electrolyte, that is limiting molar conductivity of hydrogen acetate, can be written as limiting molar conductivity, that is lambda m naught of H plus limiting molar conductivity, that is lambda m naught of AC minus. Similarly, we can write the limiting molar conductivity of HCl as the sum of the limiting molar conductivity of H plus limiting molar conductivity, that is lambda m naught of Cl minus. As per which law? As per the Kohl-Rauch law of independent migration of ions. Likewise, we can write the limiting molar conductivity of electrolyte sodium acetate as the sum of the limiting molar conductivity of Na plus limiting molar conductivity of Ac minus. In the similar manner, we can also write the limiting molar conductivity of the electrolyte sodium chloride as limiting molar conductivity of Na plus limiting molar conductivity of Cl minus. If we remove the bracket, we will get limiting molar conductivity of H plus limiting molar conductivity of Cl minus plus limiting molar conductivity of Na plus limiting molar conductivity of Ac minus limiting molar conductivity of Na plus minus limiting molar conductivity of Cl minus. On seeing the right side expressions, here there is plus limiting molar conductivity of Cl minus, and also there is minus limiting molar conductivity of Cl minus. So this plus and the minus can be cancelled. Likewise, there is plus limiting molar conductivity of Na plus and the minus limiting molar conductivity of Na plus. So this plus and the minus can be cancelled. So the remaining is only limiting molar conductivity of H plus the limiting molar conductivity of Ac minus. We need this. That is the limiting molar conductivity of H plus and the limiting molar conductivity of Ac minus. What we will get from the limiting molar conductivity of H plus and the limiting molar conductivity of Ac minus? We will get the limiting molar conductivity of hydrogen acetate. We have to find the limiting molar conductivity of hydrogen acetate as asked in the question. We are writing this equation again, that is limiting molar conductivity, that is lambda m naught of hydrogen acetate equal to limiting molar conductivity of HCl plus limiting molar conductivity of NaAc minus limiting molar conductivity of NaCl. In the sum, the limiting molar conductivity of HCl is given as 425.9. In the sum, the limiting molar conductivity of sodium acetate, that is NaAc, is given as 91. In the sum, the limiting molar conductivity of NaCl is given as 126.4. If we substitute all the given data, we will get the limiting molar conductivity of hydrogen acetate equal to 425.9 plus 91 minus 126.4 Siemens centimeter square per mole. If we add these terms, we will get the limiting molar conductivity of hydrogen acetate as 390.5 Siemens centimeter square per mole. In this manner, by applying the Kohl-Rauch law of independent migration of ions, we can find the limiting molar conductivity of weak electrolyte such as hydrogen acetate. We know that the acetic acid and water are weak electrolytes. So by applying this Kohl-Rauch law of independent migration of ions, we can also find the limiting molar conductivity of acetic acid and water. We have seen that fact in separate videos. Why should we follow the Kohl-Rauch law of independent migration of ions in order to find the limiting molar conductivity of weak electrolyte? The reason is, at infinite dilution, that is when the concentration becomes zero, electrolyte dissociates completely. That is, the degree of dissociation will become as 1. We know that when the concentration decreases, the conductivity will also decrease. That is, the conductivity is directly proportional to the concentration. So, in this low concentration, the conductivity will become so small. For that reason, it is not possible to find the limiting molar conductivity of the weak electrolyte accurately. So that we are following the Kohlrausch law of independent migration of ions in order to find the limiting molar conductivity of the weak electrolyte. If this video is most beneficial to you, you can share this video with your friends and classmates. You can also subscribe my channel.